The movies have been doing biometrics for quite a while as well. If you go back to, I guess, even fingerprint and things which were happening with fingerprint, like James Bond, Diamonds Are Forever, in 1970 that was, when a fingerprint, capturing a latent image, making a bit of plastic around it, was doing it. Later movies like Minority Report, Changing Eyeballs. Why do the movies have this kind of fascination with presentation attacks?
Oh, I guess it does make for a good story, doesn't it? And I think it's interesting that it's really only been, from a commercial perspective, it's only been in the last, say, 4 years or so that we've started to see a real significant interest at the sort of commercial side in trying to mitigate these. But as you mentioned, in the popular culture, these have been issues that have been shown in movies for decades.
Yeah, and it's not just movies. You can look at a few interesting newspaper articles. This is one from March this year, which talked about, May this year, talked about students in Mumbai who were in a chemical college doing a chemistry degree, and there was a fingerprint reader there checking on attendance, and certain students were creating a resin using that reader, and they wondered why the classes were quite low. They had 50 people would enrol and 20 people were actually in the class, and when it came to do the exams, they found that not everybody appeared to know things as well as they might. Other countries sit exams and tests for driver's licenses, things like that, and somebody else is going and sitting the exam. So what do we do about that sort of thing when those devices are out there and these sorts of tricks are being done?
Yeah, well, it just it shows the importance of having additional technologies that can help deal with these. Another example, in Indonesia, about 3 or 4 years ago, there was a very famous corruption trial with a person that was put behind bars for many years, and they later turned up at the tennis. And it turned out that there's somebody was just taking a photograph and they saw this person in the crowd. They have this system called jockeys, and a jockey is a person that goes in and does your jail time for you, if you can just pay them. And it really comes down to identity, right? Like somebody is faking an identity to be placed. So there are lots of ways in which identity processes at the moment are able to be subverted. And better technologies.
So take these fingerprint examples. What are the better technologies? What stops the 1970 resin gummy bears finger attacks?
Well, there are a range of different types of technologies that can be used. Some of those technologies involve software at the back end that looks for. So when you create fake fingerprints, anybody that's done this knows it's a fairly fiddly process, in fact, and indeed the samples themselves often degrade quite quickly. So you can look for various things when you have the image of the fingerprint, which are telltale signs that it may not be a real fingerprint. One very simple example is that real fingerprints have pores in them. Fake fingerprints may not have the sweat pores that are shown. So that's at that software level. At a hardware level, there are a range of different types of technologies that can be used that actually sense blood flow or look at other dimensions within the fingerprint itself. So rather than just looking at the surface layer of the fingerprint, look deeper into the fingerprint.
So you've done a bit of vulnerability testing around fingerprints. Are all fingerprint readers the same today?
Oh no, far from it.
And what about the basic fingerprint readers you buy today? Do they have any liveness detection in them?
Some do, but many don't. So the basic iPhone fingerprint system, for instance, the initial versions of that certainly had were very open to presentation attack. I think subsequently Apple has done some things behind the scenes to improve their resistance, but they don't mention what sorts of technologies that they're using. So I think the current iPhone is still relatively susceptible to sustained attack.
And what about time and attendance systems and those kinds of systems?
Oh, same. You mean in terms of actually deployed systems? I haven't done testing, but any sensors which are, any biometric systems which are relatively inexpensive and are using optical patterns particularly, are quite likely to suffer from these sort of attacks.
So if I'm out there buying some fingerprint biometric systems and I buy the cheapest system I can get, is that the best system to be getting?
Well, and herein lies really the issue to do with testing and assurance of systems, because if you are a purchaser of these systems, how do you tell? You're not the expert. Where do you go to make sure that you've got proper certification of equipment?
FBI?
Yeah, but FBI doesn't, to the best of my knowledge, they don't provide any actual certification of presentation attack resistance at the moment. There are laboratories around, so in the UK, the National Physics Laboratory does some work, in Europe, BSI, and there is some work that happens at NIST as well, but it's relatively fragmented, and there's a lot of work that can still be done in raising people's awareness.
So, especially with unattended devices, people who are buying those should really be thinking about not just saying we want liveness detection on this, but actually understanding what that kind of liveness detection is, what it's costing, what methodologies it's using, and so on?
Yeah, absolutely. Trying to get a sense for what protections are in place. But it needs to go beyond just reading what the manufacturer has put on the label, because often many manufacturers, particularly at the cheaper end of the market, don't really understand either. So one of the things which I always recommend is, it's pretty easy these days. You can go online on YouTube and you put in, if you're using a fingerprint system, put in fake fingerprints, and you will find online a whole lot of relatively detailed descriptions of how people go about producing fake fingerprints or fake irises or whatever. If you are very serious about the protection that your system's providing, if you set aside a few hours, you can usually follow those recipes and you can try it yourself. It's not perfect, but you will get a very good sense for how easy it is to attack something if you can set aside 3 or 4 hours, look at things that are online, and see how hard it is for you to create your own fake biometrics and pass through the system.
So here's one I prepared earlier. How hard is this?
Fake irises are...
Minority Report, take a eyeball out, plug it in, a couple of movies like that. Is that the answer?
Well, we're talking specifically about iris?
Yes.
Or, yeah. So iris is relatively it's certainly possible, and you can use fake eyeballs to do that, and there are a variety of other techniques, but it's a lot more difficult in many respects than other biometrics.
Why? Why is it harder?
Because to get the pattern that you need in order to be able... So first of all, it's harder to acquire the pattern, and it's harder to print a pattern that's able to be properly acquired by a sensor.
So if you took a pattern, printed a pattern, put it on an eyeball like this, that's not much different to the hack of the iPhone that Chaos Computer Club did with fingerprints, is it?
It's not that much difference, but it does involve a few additional steps. So for instance, most iris systems also require, so you can't just show a photo of an iris. The iris cameras themselves operate in an infrared band, so you need to be printing with special inks. You often need to be printing on some sort of surface which has reflectivity associated with it, because the camera systems behind use that. So, it is, whereas with the Chaos Computer Club hack, that actually involves quite a number of simpler steps. That's been my experience anyway.
So should we be using retina then instead of iris?
Oh, I don't know about retina. I've never tried faking that.
You haven't tried faking that?
No.
There's something you could put on a list, I think.
Yeah, well, if you find me a retina system that I can test.
Yeah. Well, every half the movies you see are doing retina systems, so there's plenty around.
Mm.
What about voice?
Yeah, voice is interesting. We're seeing a lot of interest, obviously from financial services, around the use of speaker verification. And there are a whole range of new technologies that are coming out around creating so basically training a system to sound like somebody. So you can sit there and give it some speech, and then it can basically, you type in a sentence that you want it to say, and it will say it in the voice that it's been trained by. Now, this sort of technology is still relatively new. It looks really seamless when you see it shown on YouTube, but the reality is that it's actually harder to spin up. But it does illustrate the fact that if you are using voice, you have a unconstrained, you've got no constraints on the environment in which people are using that. So they could have any sort of technology at the other end, and you need to be able to provide other mechanisms to be able to provide some sense of security. So challenge response, or there are a variety of other sorts of things that you can do.
So challenge response, what does that mean?
So challenge response is where you are trying to get them to prompt an answer, which it would be hard for them to have known in advance. Obviously, if you've got a system that can speak anything, then that's not going to solve that problem. But many of the basic attacks are where you would sit down and try and record somebody actually saying exactly what it was that needed to be said. So challenge response gets a situation where it's much harder to use a recording device to fool the system.
Because it's a second factor of authentication you're really using?
But that's not exactly second factor, because you're not asking them for additional information. You're simply prompting them to say something that they haven't said previously.
So it depends what the question is then, doesn't it?
Yes.
If I said, what's your mother's maiden name, then that might be.
It could, correct, yeah, you could use it. That if you said, what's your mother's maiden name, that would be a second factor. But if you just said, please say Africa is a country, for instance, then that's not really a second factor, that's just a liveness question.
Okay, what about vein?
Well, there are some interesting studies showing how you can fool vein using celery sticks, for instance. That was one of the famous experiments where they just basically got a celery, and the celery has the similar properties to veins in terms of their reflectivity in infrared, and they were able to enroll and fool a mock vein system. So, but I don't think there really has been enough work on actively creating fakes in veins for me to say exactly how hard that was. So certainly we haven't done work in that area.
Has there been enough work in one-to-many checking of veins
I would
in the
say,
first place?
no, I would say that's a fair point as well. There's a good deal of information about one-to-one. One-to-many is harder to come by.
So you're kind of flying a bit blind with veins, is what you're saying. They're used in a lot of banking systems, they're used for a lot of authentication. There's a lot of people saying impossible to spoof vein, it's difficult. How do you get hold of someone else's vein pattern? So what's your answer to that?
Well, I mean, it's the sort of things that has to be tested, right? You need to have people actively trying to break through these systems. And, you know, as you can see in the photograph that you've got of a person's hand there, veins, whilst you can't see necessarily all the structure, you may be able to recreate simply from an optical view of somebody's hands enough structure to be able to fool one of these systems. I'm not saying that definitely could, but, you know, hypothetically, until people have properly tested them, that's certainly a possibility.
So if those kinds of claims are being made and you've tested face, finger, iris, why not concentration on testing vein?
I guess the majority of the people that we deal with, government agencies and other banks and things, have not, they just haven't been using VAIN, they've been using those other modalities. But it would welcome more research.
So I guess that gets us to face. And face, not that long ago everyone said face was the weakest biometric. It had the lowest accuracy rates. And here we have today the iPhone X out where all the chips are in on face being the authentication factor. What do you make of that?
I think it's fascinating. Obviously, it's a real shifting point in the market, and I think it will be interesting to see how well the iPhone X stands up to sustained attack, which it will certainly get. Obviously, they're not just using face, they're also using 3D geometry as part of that. I read an article just this morning about somebody who said one of the ways that it's meant to protect you is that it's meant to detect if your eyes are open. Because if it didn't do that, then somebody could hold your iPhone up while you were asleep and unlock your phone just using your face. But in this article, they said it didn't pick up that her eyes were open, and so it was able to be unlocked whilst the person was basically feigning sleep. I think it is very interesting, and Apple generally does a pretty good job. I mean, certainly their Touch ID, while it may have flaws, actually has proven to be a very effective mechanism. But I think one of the challenges that we will face is that the types of vulnerabilities and the types of risks from one biometric are different in another biometric. And so the types of risk parameters that you are used to dealing with if you are using Touch ID are quite different from the sorts of risk parameters you might find when you're using face.
So if I'm using face on my new Apple iPhone X, does that mean that when I'm walking down the mall now, I'm going to be uniquely verified and identified in exactly the same way?
The iPhone biometrics components basically will work the same way as the fingerprint, the Touch ID. In other words, your template will just be securely stored on the device. It won't be transmitted elsewhere. But if your question is more broadly about where that technology could be used, in billboards or things, I think that's an open question.
So what's the difference between what's in the iPhone X and a surveillance camera in the corner?
Okay, so the difference is two differences. Firstly, the iPhone X has got this additional 3D sensing capability, and the other difference is the information associated with recognising who you are never leaves your iPhone, whereas when it is in the corner, with the camera in the corner, the information, your facial information, if it's to be matched against something else, is being stored in a server and matched in a server. But
I could hold up a mask and I'd have 3D sensing capability, so what's different there?
Well, that's the big question to see. So
you're going to test that, are you?
For sure. I won't be the only one.
This is a flight to Canada in 2010, and the guy on the left dressed, you can see he's wearing the same clothes there, dressed as an old guy with that particular mask on, borrowed Ted's glasses, and got pretty much all the way to Canada until got through security, got through immigration, found the mask was a little bit hot and itchy after a while and took it off, and was of some concern to the border control when they got there. What do you make of that, Ted?
Well, look, I think that these sort of mask attacks, this was a relatively early mask. I think that they are a significant threat in border control contexts. You can imagine if this gentleman had got a passport issued with that mask on or with a similar mask on, and then that mask could be given to anybody to pass through these border control checkpoints. So that's just one example. And I think that the need to make sure that you've got proper detection technology at border control points and at other places where you might be registering faces is going to be increasingly important.
So this becomes interesting. Do you think Apple have thought about this?
Will be interesting to see. I'm pretty sure that they will be aware. Whether they decided to make it a priority of the way their technology works, I guess we'll soon find out.
Yeah, I think it'll be interesting because I've heard that a lot of, on the West Coast, there's been an amount of Hollywood assistance and research gone into this so that they have taken account of some of this technology and knowledge.
Yeah, I think Apple will have done its homework, so it'll be interesting to see.
So, throwing away finger and putting face in, gutsy move?
I think so.
Would you do it?
If I was Apple and I had all those resources at my disposal, maybe. But I do think it's a gutsy move, and I think it will be interesting to see. I think that the use cases of the way people use the Touch ID and the risks and things that are associated with the way that's used are well understood now, and it will be interesting to see if they run up against a range of other security and usability issues now that they're using face.
So why would they do that, not Iris? Iris has infrared cameras, they put infrared cameras in there for face. It's a bit more complicated. Why would they go face, not Iris?
Usability primarily, I suspect. It's a lot harder to capture a iris in a way that's quick and in a way that gets you the correct resolution. So that would be my answer.
So what in the context, we've talked about presentation attack detection, in the context of masks, in the context of phones, what are we really doing there, and what guidelines are we putting out in industry around that?
So I think it's just really important. I was really encouraged by the presentation, which was before the last break, where the banking executives were talking very seriously around suspicious presentation attack detection and what they're doing. And longitudinally, it's not just about the biometric, it's about all of the other factors that come into play at the point of establishing a credential and at the point of verifying. So it's education, but I think it's very encouraging where the level of knowledge is up to, and there's still more to go.
So do you think?
Yeah.
We're just about done, yeah. So is this an impossible mission, the spoofing detection? Should we not be using biometrics because of some of these risks you're talking about?
Oh no, obviously it's not an impossible mission, but it's an evolving mission, and it's not one, just like with virus detection or other hacking techniques. It's not one that you will get to a final solution on necessarily. There will always need to be continual evolution and continual evaluation.
So we won't have a perfect system, but we'll have a strong system from a risk point of view.
Correct.
In terms of what is going on.
Yep.
Yeah? Okay. Well, thanks, Ted.
Thanks, Terry. That's good.